Who's excited to hear about who won AI Hackathon? Woo! Thank you for joining us today at closing ceremony. Here's our agenda for today. We're gonna have a keynote speaker come on. It's gonna be a fireside chat. Then we're gonna go hear from our 10 finalist presenters for the 4 tracks. Then we're gonna announce our sponsor awards, our general awards, and our grand prize winners. Who's excited? Woo! Here's some photos we took of this weekend. It was so great to see all of you. This year was the largest AI hackathon in CalHack's history.
Right. Who was at AI Hackathon 2026? So you guys. We had more than 1,300 hackers check in, 220 beginners who attended our workshops, 50 volunteers that made this all possible, 100 judges judging your guys' presentations, 50 mentors, 45 of our wonderful director team, 30 sponsors that have made this all possible, and 1 huge bear, if you got to see him. Another huge round of applause to all our sponsors. Special thanks to Annapurna Labs and Fetch AI co-hosts. You'll be hearing from them shortly about sponsor prizes. Now, I'm happy to introduce Danielle Perito for our fireside chat, the co-founder of AI startup Depth First, co-founder of Unicorn Fair, and the co-creator of Cash App at Square.
Huge round of applause for Danielle.
Thanks for having us.
Thank you.
Let's give it up for the hackathons at Berkeley organizing team real quick. My name is Jeremy Fiance. I used to help organize these when I was a student, so I know how hard it is to pull off such a big hackathon. Truly incredible work by them. Real quick, my name is Jeremy. I'm founder of the House Fund. We invest first in the top Berkeley AI startups. We're early investors in 9 unicorns and counting, including Berkeley companies, Databricks, Perplexity, Arena, and soon-to-be unicorn, Depth First here. I'm honored to be here today with Danielle Perito, a true legend, co-creator of Cash App at Square, one of the largest new business launches internally at a company of all time. He's also the co-founder of multi-billion-dollar Unicorn Fair. It's the leading wholesale marketplace. They've raised over $1.5 billion. It's a true scaling unicorn, one of the fastest growing companies, doing over $500 million in the last 12 months. And now he's the co-founder of AI security startup Depth First. Let's give it up for Danielle.
Thank you for having me. Thank you for nice.
So let's just jump in here. You've had a very successful career, but you started from a small town in Italy without an obvious network or path. Walk us through that journey and help us understand the decisions you made along the way that led you to become one of the greatest entrepreneurs and technologists of our time.
Yeah, absolutely. So my hometown is in the center of Italy, about 30,000 people. The main industry is car factories. My dad worked at that factory and made windshields. And I got really lucky in the sense that I really liked computers. So when I was 13 or 14, I started coding by myself. I had like a C programming language manual, and there was no Stack Overflow. So I had to like look up function definitions and stuff. And then when it came time to choose university, I already started having a certain need to be outside, to go somewhere, because my hometown felt a little restrictive. So that was the through line throughout my career has been, oh, this is not right. I want to do something different. This doesn't quite feel like the place where I should be. So I went to Rome, studied there, didn't know a lick of English. So I ended up going to Cambridge, where I worked as a waiter. And fun fact, I served the Duke of Edinburgh, the husband of the Queen, like 2 weeks into the job.
Wow.
I had never been a waiter before, and I lied my way into getting
That's a
the
real
job.
pressure cooker situation.
Yeah. But anywho, I remember when I graduated, I did one interview in Rome. And the guy was wearing a suit. I was wearing a hoodie. I had like cut-up jeans. And I was just like, this is not the place where I should be doing my first job. So I ended up realizing that there was just no way for me at that time. So I did a PhD in France. I went to my professor in Rome. I was like, send me somewhere. Started my PhD. I went to my professor in France, to my PhD advisor. And I was like, send me somewhere this summer. So the first summer I went to UC Irvine. The second summer I went to Stanford. The third summer I did an internship here at UC Berkeley. And then Don Song offered me a position as a postdoc, which I ended up taking. And then I was lucky enough to find Square. And then, the rest is history. But I think it's been, for you all, I think that find the thing that you're most passionate. And then just, I think the true guiding light is go towards smart people that you want to work with, that are passionate and talented. And I think that's as good of a objective function as any.
So you've worked on very different companies, Cash App at Square, to Fair, to Depth First. You also decided to do this postdoc in AI and security at UC Berkeley. I want to build on what you just said. What's your process for deciding what is worth working on earlier in your career?
So earlier in my career, it was pure passion. There wasn't like any, I call it the weight of expectations. I think people, and especially people that are graduating, should avoid carrying the weight of expectations on their shoulders. You all should be doing things that you're passionate about, that things that drive you. Because ultimately, your success will be, in large part, determined by how much time and effort you're able to put into something. So if you're passionate about something, you'll be able to put way more work than anybody else into that. And that's a beautiful thing about the world. So early on, it was just pure passion. When I did my first class in computer security, I was just like, oh my God, this looks like fantasy. There is like bastion hosts and firewalls. This looks cool. So there wasn't much thought. It wasn't like cybersecurity is a massive growing industry where if I started working in, I'll be really successful. There was none of that. It was pure passion. Now, later on in my career, as I started having to find a job and as I started having to start companies, you definitely want to put a lot more thought. Maybe my process is a little bit unstructured. It's not like I'm a voracious consumer of random factoids about the world. And I like to say that it helps me build a very good mental model of how the world works. And so, for example, when I started at Square, I didn't know anything about the tech industry. But Square felt right to me because at the time, there were companies that were doing all sorts of things that I couldn't quite understand tangibly. And instead, Square will say, well, we make money on transaction fees, and we put this little puck in people's hands, and people can accept payments very easily. And that was like something that I could easily relate with. So I think that the biggest thing is to try to take your time and study things, whatever works for you. My approach is unstructured, but some people are very, very structured. When we started FAIR, for example, I remember one of the guiding principles was, okay, there is this massive multi-trillion-dollar industry, which is the wholesale industry, which for everybody here, it's how all retailers in the world sort of stock merchandise to put on their shelves to then sell. So we're that facilitator. We connect brands and those retailers. And it just made sense to me that the fact that they were doing orders on paper or via email was not the most efficient way that we could help them order better, be more efficient, sell more. And so that made sense.
So this is an AI hackathon. You're passionate about AI. You're passionate about security, embodying the true spirit of Didaski of this hackathon. Tell us a little bit more about Depth First. What problem are you solving? And why did this feel like the right time to build the type of company you're building?
Yeah, so I stepped down from day-to-day operations at FAIR about 2.5 years ago. And I knew that I wanted to work on the general direction of AI safety. Because, I will say that I'm pretty worried about where things might go if we don't do this properly. Let's put it that way. And I think we need to have a lot of really smart people work on making sure that whatever we're building is built safely. And then I had a moment of realization about 2 years ago, which was LLMs are going to become really good at discovering vulnerabilities in softwares and systems. And at the time, it was a little bit of a contrarian point of view. And then I said, oh my gosh, if that's true, then the entire software architecture that runs the world, like the stack that runs our banks, our power supply, critical infrastructure, may just go belly up, and I think that has all sorts of negative consequences. I mean, at the time, I was mostly thinking about, sort of dystopian scenarios of Skynet launching the nukes, but you can also think about misuse and hackers and things like that using this technology. And so I think that fundamentally, Depth First is trying to tackle one of the most important problems right now in AI, which is how do we make software more secure so that with an intelligence explosion, a potential intelligence explosion, we're not going to all find ourselves just in a chaotic world.
And how would you describe the vision for the company?
Yeah, so the mission of the company is to secure the whole software. In practice, we are building an application security platform, an AI-native application security platform that helps organizations, say banks, financial technology companies, healthcare companies. They connect all of their code bases, they connect their staging environment, they connect a bunch of parts of their organization, and we help them discover real serious security issues that no solution before was able to find. And we've been working on this well before sort of like the craze that has happened over the last 2 months with Mythos. We've been able to discover vulnerabilities in Nginx and FFmpeg, and we've discovered some vulnerabilities that have sort of like made the whole internet had to sort of pause and actually fix what we discovered. So we've been doing deep research, and just to give you a sense, one of my co-founders, Andrea, comes from DeepMind, where he was working on reinforcement learning. So we have a lot of sort of true AI research DNA in the company. We're doing post-training research. But as well as for us, it's important to build a product that companies can use, not to just discover issues, but to also like triage them and fix what we discover.
Quick show of hands, has anyone used LLMs to discover any vulnerabilities? I see some half-raised hands there. Folks,
There's one over there.
There we go. All right, more than I expected. So security's gone from being an afterthought for many companies to one of the most important issues in technology. You talked a little bit about Mythos and how Anthropic came out, talking about kind of the power and the risks of putting out their new models. What has actually changed in security from a technical perspective, and what makes it an interesting space for builders today?
So many things have changed, and I think we're only at the beginning of how much focus there is going to be on security. I think that, so the mental model for everybody should be that no software is secure, and the security is not an achievable goal. There is actually a theorem called Rice's theorem that says that any non-trivial semantic property of a program is undecidable, meaning that you cannot prove security. You cannot prove that something is not going to be able to be hacked. And so we now have a bunch of very capable closed models. We also have, we're on the cusp of having extremely capable open weights models. And if you put all of these ingredients together, you find like a pretty crazy combination, because open weights models are not going to have the same safety filters. So open weights models are potentially autonomous hackers. So that's fact number one. Fact number two is what I was just talking about, that no piece of software is secure. And so, the banks that transact our money and the electricity company that is supplying us with everything, with electricity and all the critical infrastructure. So if no piece of software is secure, then what do we do in a world where attackers are going to be able to conduct attacks that much more cheaply? And I think we need a company like that first. We need a company that thinks about, okay, what is the most efficient use of AI with the most capable models at the right cost so that we can discover issues, help engineering teams patch them, and kind of stay ahead of attackers.
And so what are some of the interesting problems that Depth First is solving today?
Yes, so many. I mean, ultimately, we read all of the papers from the labs, and sometimes we're like, oh yeah, we did that before when it comes to like agent harnesses or some tricks that we employ. So we've been sort of at the frontier for now well over a year. We have a team of about 50 people, just to give you a sense. And I mean, we have to spin up containers so that we can like shallow clone a repo, so that we can like spend 2 hours of compute on a repository to discover vulnerability. Then when we discover a vulnerability, we have to hit the staging environment of our customers. And most of you probably have not worked in the industry, but you might have been interns already. And staging is usually walled behind lots of different checks. So you have to have this agent being able to talk to staging or pre-production. We are post-training models, so we are having to sort of make sure that we're building a curriculum for the models to learn, these sort of open weights models to learn how to like hack. And then, so we're having to build tons of evals. We're building evals not just for like sort of the post-training efforts, but also because we're attempting to make sure that our customers are constantly using the most efficient models. And so in order to do that, we sort of have to have a large collection of evals that is representative of the use cases that our customers may have. And then we can try to pick what is the best bang for the buck. What is the model that performs the best for each single task? And fundamentally, I think, as I was sort of alluding to earlier, that security is going to become a race between efficient security, efficient compute, efficient AI spend on the defensive side, and efficient AI spend on the attacker side. And so us help making sure that we're using intelligence effectively and efficiently is super, super important.
That's a good segue into kind of this big debate around where in AI the value accrues between the model layer and the application layer. We've talked a lot about LLMs already today. At Depth First, how do you think about working with and coexisting with these mega frontier labs, OpenAI, Anthropic, and others? And how should the audience think about this when evaluating which companies to join or which companies to start?
So I think that I try to separate this topic in two different futures. If you believe that there is going to be fast takeoff in the next 2 years, then almost no framework does any real work. And honestly, personally, I hope that we're not going to be racing towards the singularity as fast as we have so far, because I think it's pretty reckless. And I think I'm on the side of making sure that we find ways to sort of avoid an arms race with foreign countries and arms races between companies on potentially creating something we don't know. So just to philosophically, that's my standing. So first and foremost. But let's say that we don't live in a world where there's some crazy intelligence explosion in the next 2 years, for whatever reason. Either we hit a wall, or there is regulation that comes into place, whatever. I think that there are a few things to consider. Open weights models are very impressive right now, and we're seeing a collection of companies doing really, really good work. I think Depth First is one of them, but of course, Cursor has done a lot of good work with respect to post-training Composer and doing some really interesting work there. Of course, the labs are pushing the frontier on a variety of different arenas. Here's the way that I think about it. When I talk with maybe a couple of dozen CISOs every week, Chief Information Security Officers. And they tell me problems that are well beyond the scope of what a lab is likely to have time, honestly, to touch. They tell me, okay, I discover a vulnerability. How do I know how often do I have to do a scan in a world where I tried Mythos? Because we talked with companies that had access to Mythos like a few weeks ago. We spent several $100,000 on a Mythos scan. What do we do now? Do I do another scan in a month? Do I do one in 2 weeks? Do I do one when the next version of the model comes out? So there is just an efficiency play that I think you can look in companies that you're potentially thinking about joining an application layer. And then there is the fractal frontier of all of the use cases that these customers may be wanting to put these models on. So our customers want us to, as I was mentioning earlier, verify that a vulnerability that they discovered in a code base is real. So They want us to connect to their staging environment. They want us to integrate with their, workflows so that their DevSecOps teams can talk with their security engineers, that can talk with their engineers. Because security is usually a process that intersects with compliance, it intersects with various parts of the organization. So they don't want findings, they don't want just raw factoids about their code bases. They want okay, how do we close the loop? How do we put this into production in a world where I'm swamped and I can only do so many things in the day?
I want to cut at this maybe from a different angle of looking at kind of how the audience should think about what companies to join or to start. And you shared a meme with me right before this, and so I was curious to hear your mental model for how you think about which opportunities are and aren't worth pursuing, and maybe some personal anecdotes might highlight that.
Absolutely. So my career can be summarized by the Drake in an orange jacket meme, which is the one where he goes like this and then he goes like this. I don't know who knows it here. Anywho, I think my biggest piece of advice for you as you're choosing the next step in your career will be, again, find things you're passionate about. I think it's super important because those things are going to be the things that you're more likely to spend a lot of time on. Find people. I think that a good shortcut that you could use, find a person that you want to start a group project with. Even a hiring manager, as you're starting to talk with a tech company in San Francisco, that hiring manager should give you the same vibes as the person that you chose for this hackathon. Somebody that is quick on their feet, that is clearly passionate, that talented. So use the same sort of detector that you use to find the interesting people in your life. And then when it comes to the business, I think mostly just make sure that you're not joining a company that is trying to sell like sand in the desert. Because ultimately, if it's a smart team of smart people, they'll figure it out as long as it's not completely silly.
That's good advice. I heard some of your teammates from Depth First are here. Where can we find them after this?
So I think about 5:30, they're going to be in the back, and we have, I think, a booth where you'll be able to talk with some of the engineers at Depth First. They're doing an amazing job. Feel free to grab them and ask them what kind of work they're doing. I think they'll be extremely excited to talk with you. I think both of them are from Databricks, so company that has a strong UC Berkeley heritage, and yeah.
So we're going to have some folks from Depth First out in the hall. Let's give it up for Daniele.
Thank you, everybody.
I was going to say give another round of applause to Daniel and Jeremy, but you guys beat me to it. Get the slides, please. Cool. So, as we discussed, we have 4 grand prizes: Didowski's World, Didowski's Toolbox, Didowski's Lab, and Didowski's Playground. The total prize pool for these 4 prizes is $20,000 in cash. So who's excited to hear from our finalists the presentations? So we have 10 finalists that we chose among, like I said earlier, 460 projects that we had this weekend. We have 3 minutes for pitch and then 2 minutes for Q&A. So without further ado, let's introduce our finalist judges who are going to be judging these projects.
Right. A big round of applause to the finalist judges that are helping us judge these projects. First up, Adam Yala, who is a professor at Bayer, and Volo.
Hey everyone, excited to be helping judge today. I'm co-founder and CEO of Voyo, which is a neolab for healthcare building radiology foundation models. And I'm also a professor in computational vision health, computer science, and stats. And excited to help see what you guys have shipped and help choose.
And next up, let's welcome Bryce Gilliland from the Cal Innovation Fund.
All right, hey everyone. Very excited to be here, excited to see all these projects. I'm the general partner at the California Innovation Fund. We invest in founders that come out of the UC system, focused on Cal, and then we donate half our carry back to the school. I'm gonna go now.
Next up, let's give it up for Jen Wong from Felicis.
Hi, everyone. Really excited to see all the projects. My name is Jen. I work at an early stage venture firm called Felicis. We invest anywhere from $1 million to $20 million. We're generalists at the end of the day, investing across AI and hard tech and defense. So if you're building in any of those areas, we'd love to see you.
Next up, Perla Gomez from Foam.
Hi, everyone. Excited to be here. I'm Perla from Foam, founder and CEO. I'm working on making production legible and accessible to all, whether they're technical or not. My intern is here today, so I'm very excited. I also went to Berkeley, and I did some of this stuff, so I'm very excited to judge you.
And last but not least, let's give a big round of applause to Phoebe Yu, who was previously at Amazon and Visa as a UX designer.
Hello, everyone. I'm a UX designer previously at Amazon, and now I make content on YouTube discovering the design, psychology, and culture of things that we build. So asking why we build the things we build. I'm excited to see what everyone has in store, and thank you.
So our first, let's bring up our first presentation for today. Just give us a moment to pull up the slide. Drum roll, please. First responder relay. Woo!
Hello everyone, good evening. I am Moksha Agarwal. I am student of San Jose State University. I recently graduated from Applied Data Science. So my project is first responder relay. So wildfires are really common in California. And whenever there's a wildfire, there are like thousands of calls and most of them go unanswered. So I built a system that can respond to them. And also, 1 in 4 person in California is non-English speaker. So it is also has 13 language support in that. This system helps the dispatcher to connect urgent calls with the 911. And so they are able to manage multiple calls. So this was my dashboard. I hope you are able to see the map. And this is the map. And there's like the mock fire zones that I have made. That's the Twin Peaks, Mount Hamilton. And so these are based on calls, and it identifies it 3 categories: urgent, guidance, and info. So urgent is the one that 911 will reach immediately, and guidance is one where dispatcher will guide, and info is based on the agent can provide on automated responses. And so yeah, this was all the tech stack that I used. I used Claude. Claude is the one that categorizes all the calls in urgent, guidance, and info. And DeepGram is the voice agent. I cannot show you the live demo, but the caller can talk to them and tell their address. It will identify the zone in which they are in, whether it's near to the fire zone or not, and whether do they need evacuation. it also helps, DeepGram is the one that helps in the multilingual support. And Redis is the database that cloud stores the database for all the session readily. And Mapbox is the one that's running for the maps. And Arise is the one that evaluates the Claude's responses, its latency. And so this was my tech stack. And yeah, so these are some of the screenshots from my application. These are from mobile. It also has, like I said, 13 language support, so Spanish, Hindi, and all the others. Yeah, and so yeah, I tested it on 30 calls, and it recognized 100% language accuracy, 90% urgency requirement was correct, and addresses were correct, 100%. Hopefully, the video is. If video is able to. All right. So that's all from my side. All right. Yeah.
Hey, how many Bay Area residents are there in total?
Sorry?
How many Bay Area residents are there in total?
Bay Area?
Yes. Do you know the head count?
Sorry, I'm not.
How many residents are there in the Bay Area?
Like thousands?
Okay.
Over lakhs?
Yeah, curious, because that would be pretty huge
Yeah.
impact, 25%.
Yeah.
Do you know the difference in response time that this would enable?
Response time in the calls, there's some latency in the callers. That is mostly from DeepGram's API. That there's some latency, but it's mostly like into 20 to 50 milliseconds. It's sends the response to the dispatcher currently.
Do you know the difference, though, that this will enable versus current methods?
What is the current situation in the
Like current methods, it takes 12 minutes to respond. With this, you think it can move down to 7?
I don't have the market research right now.
What would it take for a local police department to be able to use the system? And like, what would rollout look like?
So this is not like, I would say, they can use it as an assist, but they cannot totally rely on it as it uses AI agents. There's quite a bit of accuracy, but still it is just helping the 911 responders to identify which call is the most urgent one. So yeah, they can integrate it in their system as a support system.
Were you able to show this prototype to any real users and get their feedback?
Yeah, in the hackathon, there were I showed it around to my friends and obviously the judges. So their response was good about the but the criticism I faced was so there's Castro Street that is both in Mountain View and San Francisco. How is it going to identify which the caller is going to respond to, right? Which is which street. So these are some of the things that I can improve on that I got the feedback from, and yeah.
Thank you, first responder.
All right, thank you, first responder. Next up, we had Lucid Voice for the second finalist for Jadowski's World.
Hi everyone, we're Lucid Voice. I'm Dhruv.
And I'm Rishabh.
So what is Lucid Voice? So Lucid Voice is an augmentative alternative communication interface that gives people who can't speak their voice back. So with just a few taps, we generate a fully fledged sentence in your own voice.
Conditions like aphasia. Yeah. But what is going on? This is great. Conditions like aphasia, autism, cerebral palsy, and ALS are just a few of the many conditions that plague nearly 100 million people in the world, preventing them to speak the way they want to.
However, the same two words don't hold the same meaning for everyone. So we use the context of the situation, the listener, and your typical voice to determine how exactly we should be generating these sentences for the user to utilize.
And each reply is sourced in a personal memory graph, which works in real time, allowing the user to train their data and learn effectively.
And we made sure this entire interface runs completely locally with a local model and none of your sensitive information ever leaving your device.
All right, so this is a representation of our brain. We don't have the live demonstration, unfortunately. But as you can see, the points on the brain are the nodes, and those nodes represent points and relative pieces of the person's life. So the person themselves, the relationships they have, the people they're connected to, their behavioral patterns, all of those are stored within the nodes. The lines connecting the nodes are the edges that possess the connections between those nodes. So who someone is to the person, what they're trying to say, those contexts are all stored within the edges. And effectively, our idea behind this was to take a point from actual biology, which is things that concepts that fire together, wire together, and we took that and we implemented it literally. So essentially, patterns and pathways that are used more often tend to show up more in our model, and paths that are used less often fade, just like our actual memory does. And we use this to essentially go from being able to take this and inputting just 2 words, and based on the context of the question, being able to identify what the user is trying to say.
So this is a given example of talking with the local LLM for populating the brain. Since if we have more information and more nodes, then we'll be able to give out better results. And so as you can see, with just 3 words inputted, 3 separate generated sentences appear. And the way that these sentences are generated is that first, the query is made with the original inputs of what the user wanted to say, and those are used as anchor points. And we traverse the graph outwards, looking for semantic similarity. And then we run submodular optimization, which in our case is modeled as a greedy facility location maximization problem. And that gives us the set of facts that are the most relevant and least redundant. And we use that to make a second call to the LLM with the personal communication profile. And that gives us together the generated sentences that the user chooses from. Thank you for listening to our presentation.
So does it take the brain to figure out how to make sentences a lot quicker so that there's less buttons for them to push?
Well, the brain is there so that it has more context and information about the person using the interface. Since think about how your brain works when someone asks you a question. You don't specifically instantly come to a response. You have to think about it. And those are neurons firing with the connections to them. And so with more information in the brain, we can give a more accurate response to how the person would respond if they weren't affected by any of these conditions.
And then do you know how many people this could serve?
What was that?
Do you know the populace that would be enabled by this?
Yeah, so the populace is about 97 million people across the world. We had a slide on that. And about 5 million people in the US who suffer from these conditions. There are currently some solutions out there, but they're much more ineffective as most of the physical devices that they have are rigid, no adaptation, so only 15 to 20 total words, and they speak at about 8 words a minute. Our implementation takes a step beyond that and tries to aim for that actual talking, speaking level. So we can hit about 100, which is 2/3 of the speed of 150, which is the average human speech per minute. And that was the goal behind how we wanted to build it.
And then do you know the market for that? What their willingness to pay is?
Well, we looked into that. So there is an association called NAA, which is the National Association for Aphasia, which is like the main condition that is affected when trying to say something and not correctly finding the words when you want to say it. And so their current solutions, like as he mentioned before, the devices, they're slow, they're clunky, they cost hundreds of dollars. And sometimes that's the only way that these people can communicate with others. And so we believe that there is a very large market for this, and a lot of people would benefit greatly once we fully fledgedly develop this.
So you literally give people a voice. Why this project?
We decided on this project because when we were looking online for problems that didn't really have a good solution, we stumbled across this YouTube video with a person suffering from Bracco's aphasia, and he had the level of comprehension he had before he had his mild stroke, but he couldn't ever find the words that he wanted to say. And he was working with someone else to be able to communicate with others. And we just felt that since we have much more advances and leaps in technology, especially with local LLMs being able to run on your device itself, we felt that using those solutions to give a much better adaptation for the device so that they can communicate much better with other people.
Last up for Dosky's World, we have Snap Cycle.
Eighty-nine percent of Tier 1 university students didn't know how to dispose of their household items responsibly during move-out season. That's a pretty high number. And this results in many students resorting to illegal dumping, which is basically taking all your items from your house and throwing it on the street. And in 2025, that led the city of Berkeley to spend over $500,000 cleaning up this mess, as you can see here. And it's not just the money, it's bad for the environment, it's a public health hazard, and local residents are really angry every year because their lawns are getting trashed, right? But honestly, it's not entirely our fault as students. Disposal services are scattered across the internet, and it's really hard to find the one that suits your needs. And that's where we come in. We're Snap Cycle.
So this app basically doing is you take a photo of that, scan the item, and we will tell you what to do.
And then after the model has, the Gemini vision model has identified what the actual image is. As you can see here, we took an image of a stool and it showed the stool with the cushion and gave a very strong description. Under this, you'll be able to actually give notes because based on the condition of the actual product and based on how much wear and tear it has, that can change its value. And if you want to recycle it, then based on this, there are different options. So obviously, if you have like a Red Bull can or something, then that's more obvious for actually recycling, or throwing away at that point. But then if you're having like a chair here, you won't just throw it in the trash. So you'll actually want to go out and have an opportunity to donate it, or go out and have an opportunity to actually give it to someone else and recycle it to someone who may need it. So there are many different options in the area based on the zip code information that we collect at the start of the entire process. Oh, yeah. So first off, the actual multi-agent pipeline of this entire process is that, as I was saying before, the Google Gemini the Google Gemini vision model will first look at the image and analyze based on trained images in the past, seeing how accurate this is to other images, and then actually analyzing the image to give a final answer. And then from that point, it is able to then give text synthesis of actually explaining what the model is, and then explaining how the model goes through the entire process of finding the image, and then understanding if we actually need to donate it, or if you want to move forward and just recycle it.
And we also use browser-based to build a rack database for it, and we use Redis to query it.
Yes, and then after using this Redis stack, because of the fact that we're on now thinking about the act stage, so thinking about, okay, so now we know that you're trying to donate it, or you're trying to actually give it to someone in need, maybe through a city service or some kind of service to actually recycle it, then you're trying to get in touch with these different businesses. And so there are many different ways. So a few of the ways are, one, using Twilio. Twilio is a service where through the Redis stack, a Redis agent calls Twilio and then is able to send a message straight to from you to the business autonomously. And there are many different processes also, like using a phone call and also autonomously sending messages to actually solve the problem more efficiently.
Yeah, so for our backend and database, we use Supabase. It was very easy to deploy and user-friendly. So we store our auth, so username, login. We also connect it to Google. Also, we store small pieces of data where we know the user's preferences on what kind of waste services they would prefer over other waste services. Yeah, and so our program is a very agentic, heavy relied on program. So it's very important for us to have every single part of the loop operational, or it will be very easy to break. So we created this reinforced debugging loop called Reflex. One of our two of our sponsors, Sentry and Arise, both collect data and logs from our AI agents and our application. We put those data together and we send it to Claude Code. Claude Code will automatically apply fixes and changes, record that, and also leave documentation inside the Markdown files. And it's an infinite loop of that, so we never have a breaking application.
All right, thank you, and we're SnapCycle.
I guess I have two questions. How fast is this from the first step to when I know where to throw this away? And I noticed you really focused on this reflex thing that tells you how the agent is doing it. Like, why did you, what drove you guys to focus on that?
Yeah, well, firstly, in order to get your first response, taking the picture and processing the picture takes around 10 seconds, and then going through our vectorized database and pulling it using an agent takes around another 10 seconds. We give around top three results around your area, and then other stuff around national-wide chains for waste management. The reason why we really wanted to focus on the reflex was because, as I explained to you, our application is a very heavily relied on agent system. So if any part of that loop breaks, that is a critical part of our application. So we really wanted to create a system where we can keep our app up while using these agents.
Could you share more about how you're thinking the user incentives? So like, why does a user go on the platform to learn about this? How do you incentivize this to grow?
Yeah. Okay, so basically, if you are caught for dumping illegally, there's like a $500 fine that the city imposes if you're caught. So that's one incentive. Another incentive is that there's just a good feeling that you get when you donate an item to someone in need, or you do something that's positive for the environment. So I think those are some incentives. In the future, we're trying to pair it with a nonprofit that I'm trying to start in Berkeley, where we have a leasing-based marketplace where students can donate items that will be leased out. So donate in May, and the items will be stored over the summer and then leased out to incoming students in August. And we can incorporate this app into that nonprofit so that like we can offer incentives for students to like also use our app, like maybe a discount for using our app for like leasing our furniture. Yeah, so that could be another incentive.
Also, one other thing is that UC Berkeley, especially, and a lot of other universities in the area, do have a big problem with this. As during our presentation, during our research for this, we were seeing that UC Berkeley has many instances of students, especially during move-out season, just leaving many different sofas and just massive furniture outside because they are too busy to actually go and donate it and do those things, which is why we wanted to focus on having an autonomous purpose of being able to make the process as easy as possible for UC Berkeley students and students in other colleges to actually go and recycle these and use the resources that their city has and use the resources that this app, that local businesses offer to be able to recycle and use those different facilities.
All right, thank you, SnapCycle. We're gonna move on. We don't have a lot of time left, and yes, thank you. Next up, Inspector for Dosky's Toolbox.
Hi, we're Inspector. I'm Tiffany. I'm studying CS and Math at Purdue.
Hello, my name is Wesley. I study CS and Math at Georgia Tech.
So if you're in this room, you probably vibe code, and if you vibe code, Inspector is for you. AI coding agents have increased developer speed hundreds of times in the past few years, but bug rates are up over 41%. Why is that? Because your agent just writes the code and then hands it off to you to launch it, click around, find what's wrong, and then describe the bug in detail back to your agent, one bug at a time, over and over. So you're basically the QA engineer. Inspector aims to close that loop. What is Inspector? Inspector is a MCP server that connects to any of your coding agents like Claude Code, Cursor, Codex. And what it aims to do is, when it's called, it launches your app in a sandbox and then uses computer use to navigate it. It detects the buttons, the input fields, and then tries to use your app like a real user would and tries to break it, find all the bugs that it can. And then it will surface those bugs back to your coding agent as well as to a dashboard. And from that dashboard, you can also tell Devin to write a PR to fix this bug. Additionally, Inspector is multi-agent. So first, we have a coordinator agent map your UI into different regions, and for each specific region of your UI or your app, it'll send a sub-agent to tackle that and just try to break that part and find all the bugs in that part of your app. So it finds all the UI defects, crashes, bugs, etc. And then it feeds these back to your agent or to the dashboard. And this is a quick high-level overview of the architecture. So you can see that Inspector sits as a layer in between the coding agent and your sandbox app. We support not only web, but Electron desktop apps, Android, iOS, native macOS, and more. So we're trying to basically service all of these and not just web apps so that people building different kinds of apps can use this as a QA agent in their development process. And additionally, you can see that Inspector acts as the eyes and the hands for your coding agent to see and navigate on your app.
Here is a quick demo. So this is the landing page. You can get the MCP. Two of our most important functions are test app and test app in parallel. The parallel agent will spin up a planner and it will look through your app and plan out 3 sub-agents, specifically right here. And basically what this does is launch the computer use agents and click through your app. So after that, it will surface your issues, and you can use this as context inside of any agentic development tool, or you can use it as in the dashboard. And the dashboard here shows the 3 different parallel agents running at the same time. It's all launched in a virtual environment. So for each agent, you'll see a replay of the agent clicking through your app inside the VM, and that is a replay where it goes through and shows you the different issues. That's a specific issue in the
All right,
input field.
last slide, guys. Sorry.
Yeah, that's in the input field. And either you can fix it with Devin or you can fix it in Claude Code. So this shows Devin fixing it, and then in a bit, it will be merged. Next.
So yeah, this is just another quick view at the UI where you can view agent runs and findings in your dashboard, replay the agent runs, and then use Devin to create PRs.
Thank you.
Thank you.
What sources of data do you hook into? Because these applications are very noisy, so.
Yeah, so the planner agent takes in the DOM and also context from your previous chats because we want to ensure that the specific issues and evals are like correct, right? And this can not only be just functionality, but also for preference. For example, if you have a reference to a like a Figma design, this is like your ground truth, and you want to ensure that this is exactly matching your app. And at the end, when you surface the issues, we have like an eval stage that tries to increase precision.
How does Inspector know what a bug is? So like, let's say he clicks a button and the wrong row goes into the database. How would Inspector know? How do you think about specifying the right behavior in this flow?
Right. Thank you for the question. So during the planning phase, we get all of the information in terms from the code base for functionality purposes and also context for specifically understanding how do you want this button to be placed, right? So to ensure that this is correct, you launch the app and then you click on different things, and the console log will give you specific feedback as well as the visual, the computer use. We'll take a screenshot and also use this as a way for evaluation.
Like, people are kind of vibe coding and putting in less and less prompts. Does it project out what it thinks is the right answer to debug against that?
Yeah, at the end, when all the different things, all the different bugs and specific errors that it has found is surfaced, that is the part where specific engineers, like who's agentically coding, will know if like, oh, is this the correct errors that has been surfaced? If not, you continue to iterate in this. And what we're trying to solve is the agentic development process, especially like with a human, because when you're continuously developing in this loop, you want to ensure that specific requirements match whatever you're trying to develop. You're not just trying to one-shot this whole process, especially for UI UX.
Thanks, guys.
Thank you.
Thank you.
Thank you. Next up, Iron Book for the second finalist of Dudowski's Toolbox.
Hey guys, thanks for coming. My name is Praneeth. Hi, I'm Langdon. And this is Iron Book, a living manual you can walk into. We wanted to do something ambitious, but first let's start with the problem. That's us. So the old baby boomer population is retiring, and when they leave, their knowledge leaves. And specific to manufacturing, this leaves a lot of holes empty. As you can see on the slide, 11,000 Americans turn 65 every day, and as these Americans retire, their knowledge leaves, and that's really bad because these corporations have to take on the brunt of it.
Yeah, so current solutions right now are like manual 2D papers that you have to kind of look around, and it's like a lot of diagrams and numbers. You can't really interact with it. And also there's like CADing and 3D scanning, which takes a lot of time and it's really expensive.
And the key here at the end is that none of them actually capture any spatial knowledge.
Yeah, so a little bit about the industry. A lot of money is lost from like onboarding these people, or a lot of time spent documenting the little nitty-gritties of the manufacturing.
And yeah, looking at the industry, as agents evolve, they're not just a chatbot anymore. We want to try and get as much context into them as possible. We've seen this with websites. For example, Claude uses Playwright. We've seen this with audio and visual processing. But one thing agents really suck at is understanding what a scene actually looks like in 3D and navigating around it, which is what we're trying to solve.
Yeah, so this is basically our project in one sentence. You basically, oh, we'll get into it through the demo.
Yeah, so you walk around a machine with your phone, and we turn it into a 3D world. So there's 3 steps. First, you capture. With a phone, you just walk around an object, and you capture it. Then you reconstruct it. We used a model called Colmap with Gaussian splatting. You'll see the demo, see what that looks like. And then we have an agent where we can ask questions about what's actually on the screen. Yeah, so here's an example of a bike. It's a bunch of images taken around a bike. And if the demo runs, you can see that we created a new 3D world. You can see the bike there in 3D. Here's our navigation agent, where we ask it, for example, I forget what I asked. Zoom into the engine, what engine is shown on the screen, and like maybe some details about it. And what the agent is doing here is it's running a loop, so where it takes a screenshot, and we made specific tools that connect to the agent, where the agent is able to move around in 3D. And you can see here it's zoomed in on the engine, and you can see a description on the right. We tied this specific to manufacturing. If I'm a new hire at a manufacturing company and I want to learn how a piece of machinery works, I can do the scan and ask questions about it. And you can see here I ask another question about the headlights. I ask, like, what headlights are these? And it is able to tell and navigate. Here's some pictures.
Yeah, so our target users are, first we're looking into like the manufacturing world. So one, it would be like a new hire trying to understand like how the floor plan works. They just take a couple photos of the machinery, and then they can just really go into it, the nitty gritty. And then also like the person who's about to leave, they can document their knowledge of the floor plan. And finally, like the manager who wants to keep this knowledge.
With this use case, we're saving manufacturing companies a lot of money, but in general, an agent should have the ability to understand 3D context. The tools right now are like robotic simulators, but that isn't really like what you interact with day to day. There's no real good MCP that interacts, like if I want to scan around this A, for example, there's no real like tool that I can use to scan around the A and ask questions about it. Yeah, and there's a lot of fields that it's applicable in, from like healthcare to real estate. And in terms of where we'll go from here, first off is agent generation. So right now the agent is able to reason about what's there, but it's not able to generate things. So for example, if I went to the motorcycle and I was like, detach the wheel from the motorcycle, what does that look like? That's one place where we're trying to go. Fine-tuning models, faster 3D model generation. We're running this on our MacBooks right now, which meant it took 40 minutes to actually generate, which was horrible. And more tools like VLMs where we can get more information from the models. But yeah, that's kind of the general idea of it.
So you went from images to 3D, right?
Yeah.
Where's the institutional knowledge at?
Sorry,
So where is at these factories and et cetera, like from the image to 3D, where does the institutional knowledge lie? Like, where is it?
Oh, I see. Well, that's kind of in our next steps. So you can see here we said fine-tuning models. Each company can fine-tune their own models based on their own machinery. But in general, if I'm a new hire and I want to understand how a piece of machinery works, that's not really institutional in a way. It's just kind of machinery-based, which is what we're trying to solve. Hopefully that answers your question. Okay, cool.
I think part of the gap was that these people are leaving the workforce, so their knowledge of that is leaving. This presents them with what the engine is, but that could be found in a book. So what's that gap of replacing this labor and that knowledge?
Yeah, so the question we asked was kind of basic. It was just like, what type of engine is this? But in like a more complex piece of machinery, where you have more images and more detail that you can record with your phone, you can ask more specific questions, like how many gears are in this machine? Or
even like specific measurements that require.
Just like any machinery-related knowledge that the old expert might have had, we're trying to acquire.
Do you guys know which markets you'd go after first?
I'm glad you asked. We have a slide on that somewhere. Yeah, I guess the biggest market is just like these manufacturing companies because they're losing a lot of money in trying to get their new hires up to context. on machines that like only one person knew. So you can see here, 250,000 US plants is a $2.5 billion market. Obviously, there's still a lot more work to be done in fine-tuning and getting better tools. But it's a really big market, and I think 3D context for agents is just really big in general.
If you have a new person in a manufacturing plant, what do you think is the hardest thing for them to learn in those 4 years of apprenticeship in the ramp-up?
Sorry, could you repeat that? I couldn't.
When you have someone new a new apprentice in the manufacturing plants, what do you think is the biggest bottleneck in their own personal growth as they learn, say for the first few years, as you had that slide, like it takes 4 years for them to get up to speed?
I guess it would just be being comfortable with the general environment that you're working with, which is exactly what we solve. It's like understanding your physical surroundings. Like each of these machineries, like it's kind of like, they're kind of like, I guess, like static, like they're kind of like, they stay throughout the generations. And a lot of them are like legacy old ones that have, maybe some of them have documents, not a lot of them do. So I guess the main issue that's pressing is like just understanding your environment, I guess. And this is exactly how to do it.
Thanks, guys. Yeah. Thank you, guys.
Thank you. Up next is Sentinel for the third finalist in Dosky's Toolbox.
Hey guys, my name is Sudarshan and I'm a triple major at Purdue.
My name is Isha and I'm also a triple major in Purdue.
So we have built Sentinel, so let's start about it. So basically, let's start with why we built it. So our use case is actually from our campus at Purdue. There was this one Mexican restaurant that basically had a website built by like one of our like students. Yeah, not throwing shade on them, but like he built it really bad. So basically you could just go to the URL and at the end of the URL you could see something like T140, which basically meant table 140. And if I just went to the URL and typed in table 139, I could order for the next table beside me. So yeah, and they lost a lot of money because of this. So we're basically here to solve that problem. So that's why we built Sentinel. So you can basically say it's an agent security layer on top of your website. So we basically built it with Fetch AI. So we built 5 sub-agents and 1 orchestral agent, which is basically like the manager for the 5 sub-agents, which are basically like the interns. So yeah, it starts with each one of them are like trained specifically on one computer security breach protocol. So for example, SQL injection is one, URL tampering is the second one, and stuff like that. So moving on, this is how our product looks. It's very easy to use because that's the main point. We want anybody, whether you're 16 or 80, you should be able to use it. Take your GitHub URL and put it on there and hit start the scan. And it should bring up to the dashboard, and Ishita can talk a bit more about that.
Okay, so what we're looking at is called the breach. So this over here, we have a whole dashboard where all our 5 agents are right now injecting and going through the whole repository, which we're using GitHub's as our backend, and we're using, as we're going down, do you want to go to the next slide? And it becomes a report. And also right over here, we're using browser base. So browser base is basically holding our isolated real-life browser, cloud browser. So for example, you have a website that you deployed. I'm pretty sure many of you guys have deployed all your websites today, right? You can put that website link, and it will basically go through the whole, the 5 agents will go through the websites and will tell like where the website has flaws, what vulnerabilities it found, and what other issues they had found. Can you go to the next
So basically, the agents, we have actually talked to a company regarding this. So they're this shady Vietnamese place, like 2 miles from here. So they basically do not have a website until like 2 years ago, and it was built really bad. And we can see that this is our agent, one agent going through the website. The agent basically is trained well enough that it screen records itself opening a browser tab and takes screenshots at important moments. So this is one example. Previously, we ran it on Ishita's Prime video. That's why, yeah, you could see that. You could see her Prime video on there. And that was screenshots from her Prime video. So we're just going to skip ahead. So we do help fix the problem, and we do open PRs. So this is how, whether you're 16 or 80, we can fix your problem. We do open a PR. This is a PR built by our agent. This is the orchestral agent because it's fed info from the 5 sub-agents, and that's how it looks. we did build a lot of features. I guess we ran out of time. We built a VS Code extension. We built a Chrome tab. And we also did build.
We also have agent discovery, and it can discover all your agents and also add security layer to your MCPs and agents too.
Questions?
I know we said a lot.
So in the beginning, you gave the example of the restaurant, like people ordering for other tables. How does the agent know what is something that has to be fixed?
So like I said, we have 5 sub-agents. I'm happy I can speak a bit slower. We have 5 sub-agents, so each of the agents are basically trained to be white hat hackers at one specific domain. So the first one, like I said, is SQL injections. So it does run 20 iterations for specific injections, and once it's out of iterations, it gives a check complete, but it does mention that it did run out of iterations. Similarly, for the URL tampering, we have iterations where it tampers with the URL. So basically, each agent acts as if it's a white hat hacker. It just opens, each of one opens a Google Chrome tab and basically tries to attack it. And if it can attack it, it sends a screenshot like, hey, I have your data. Are you sure you want this to keep going on?
Like we said, we use browser-based. So browser-based shows a real time, like how to use the website. It's just like think of a human using the website, and it basically has a whole stored in the database.
So defensibility is my biggest concern here. How do you guys think about your moat?
Could you repeat that? I'm so sorry.
I worry about defensibility. There's a lot of people who are kind of building in this space. So how do you think about what's unique here?
So we did do our competitor analysis. Our biggest competitor, I would say, is SemGraph. I work for IBM, and I do the security part of it. So we do see, like this, my manager and I was talking about this last week. He's like, there's a lot of people who do this for big corporate enterprises. And like IBM as a whole, we charge like $3,000 a month for like our product. And like I said, the person who makes Mexican food at Purdue probably can't afford that. So we're trying to make this for the low-end clientele, which, yeah, we think it's a pretty good idea.
A lot of security issues and breakpoints happen when someone's trying to impersonate someone else or social engineering, and that doesn't come from the code base. So how are you thinking about those?
So our agents cannot impersonate anybody. I wish we had a live demo here. So the Vietnamese restaurant, for example, is a good demo, but we also tried it. So I don't want to pay to watch the World Cup, so I like go on shady websites a lot. So there's a lot of clickbait. So there's like 2x's, you don't know which one is the real one, and like you end up clicking the wrong one and it takes you to another shady website. This is a good example because when our agent does, we have a clickbait agent, that's our 5th agent. So it clicks if it clicks the wrong X and it takes it to the shady side, it immediately hits a guardrail and it does not be able to access that site. Like similarly, it does have access to Google, so we did build guardrails. Yeah.
And we also use Redis a lot. So Redis is like caching and storing every person's like data, and every time it's making the caching, it is also giving that that data to the agents, and the agents are able to go and like learn from it and also keep improving. So if they see the vulnerability happening again and again, it'll know when it happened, like, and how to fix that again.
Thank you, Berkeley.
Thank you.
Right, thank you. Next up, StudForge for the first finalist of Dudosky's Lab.
All right. Hi, I'm Patrick. I'm an incoming freshman at Caltech.
Hi, I'm Mike. I'm an incoming sophomore at Indiana University.
I'm Jerry, incoming freshman at Berkeley.
I'm Haroon, and I'm also an incoming sophomore at Indiana University.
And we built StudForge. So our problem is that simulations are a very important part for advancing robotics research. However, simulations is also the bottleneck as well, as they're very expensive and also slow. And we have metrics from a study up here where they, for 13 robots, it took them 17 months to create a data set of 130,000 simulations to fully train them. So as you can see, it's very expensive. And then also, in addition to being slow and expensive, current simulations are very like high fidelity, and as a result, they have to be made manually. So made by hands. And in this other study that we found, this lab, they're only able to make 4 high fidelity maps for training their robot agents. And as a result, instead of actually learning, they just memorize the maps. And our solution for that is to be able to generate lots of very, very cheap and fast maps to be able to train these robots.
All right, so we're jumping straight into the demo. So it loads up and it does something called world building, which is essentially building a model from the ground up, as you can see right here, based off whatever the user prompts into their code. And right here, we zoom in, we get a good little view of our little cute agent robot swarms here, and we have them running a little free. So they're scurrying currently to each of their own respective objectives, and it's reflected in the dashboard on the right. We'll get into that later. But something really cool we decided to pivot to was we actually used Midjourney to create custom textures. We used their MCP and also their image creation design to create like a realistic overlay for, you know, a better look. We also added first person for a more in-depth look. And then we also decided to go with that CAD design that you saw earlier. Very, very basic, very engineer software-like.
Yeah, so let's talk about why does it look like this? Why are there blocks everywhere? So what we realized is that with these high fidelity simulations, really the only thing you could do is observe and capture metrics from them. And you're not observing any actual behavior between the agent interactions themselves. So what we did was we compressed high fidelity environments into these very rigid and structured modular blocks, which is inspired by our love for Legos. But this way, it's trapping rich semantic context into these blocks that allows these agents to traverse the environment very, very easily. And we have 3 observer agents actually looking at the environment externally, which are able to measure these agent interactions. And it creates a very positive feedback loop because then we're able to measure collisions, mismatch and coordination, and that helps us with model generation in the future too. So yeah, that is a basic rundown of how we're creating this compiler for new world generation.
And if you're wondering about the studs, it's because we really, really love Legos.
And then we'll now open the floor to any questions.
Which kind of robots do you imagine this being a good training environment for? So there's a lot of work in robotics right now when like household chores, washing dishes, which seems not quite suited for this, or like Amazon style moving around boxes. So like which kind of physical robotic skills are you trying to solve here?
So there's a lot of like different use cases. The one that we were kind of thinking about targeting when we made this was actually for like search and rescue, where like it's search and rescue. There's like a lot of different environments that can need to be generated, and it's very hard for you. Like if it was like a warehouse, then maybe memorizing like a map of the environment wouldn't be too bad. But in search and rescue, it's very unpredictable, and thus you need to be training on these very modular, generative, and very original environments rather than using like the existing like high fidelity like stuff like NVIDIA Omniverse.
Yeah, just diving deeper into that. So search and rescue, I'm imagining you have robots with like, weird locomotion and all those kind of things to actually maneuver around, say, a burning building. How would you build in the specific physical parameters of the actual hardware you're dealing with, something overheats, all this kind of stuff into this kind of simulation?
Yeah, so talking about what's happening under the hood here. Basically, when you input this prompt into the generation, it's creating a structured scene graph from Claude, first of all, which is placing these models, basically labeling the models, structuring where everything should be, and it's basing that off of the canonical USD protocol, which is how typical robots or training simulators are basing their assets around. So basically, once we have this structured scene graph, which is based off this canonical USD representation, then we're able to export these features that you're talking about for maybe they have like these specific robot arms that you want to see how those are interacting with the environment. So basically what we have here is the compiler layer that can then be exported to whatever simulation you want, for example, Isaac Sim on NVIDIA's Omniverse, right?
We're at time. Sorry.
Thanks so much.
Thank you.
Awesome. Next up, we have TheraCat for the second finalist of Dudosky's lab.
Previous one. The right. Okay, we're ready. Okay, hi everyone, how are we doing? Anyone here hasn't ever experienced anxiety? Raise your hand. Oh wow, there are people who hasn't, okay, cool, you're blessed. Okay, anxiety is real. I'm a mental health clinician working at Kaiser with 3 years experience sitting with people at their hardest time, including severe anxiety and panic attacks. Panic attacks is not only anxiety, it's like feeling like you're dying, you're like literally shaking and choking, you cannot breathe, you feel like, oh my gosh, I'm going to die. And there are literally more than 10,000 people committed suicide because it's so painful. But how could we help? Yes, we have therapy, that's my job, but I cannot always be in the room. We have apps, but when you're like shaking, how could you open an app? We need something to help. That's what brings me here. What if we have a wearable device that can proactively help when things happen? That brings us to TheraCat. This is Sarah, this is Cat. So, what it does. First, we have sensors here that detect the patterns of panic attacks based on personalized machine learning trained models. So when it sends, oh, you're experiencing panic attacks, it will automatically provide physical intervention using this little band. It will tighten and release so that can guide you through grounding breathing. So it's more efficient and more effective than following instructions by vocal instruction or some app. At the same time, we have this little cat. Its ears can move, it's super cute, and also it can work like a therapist talks to you. Let's see a video. So see, okay, I'm experiencing panic attack, and you can see they start to spin, and so it can tight and then hold. So you breathe in when it's got squeezed, and then breathe out when it got relaxed. And the cat is moving its ears, super cute. It's therapeutic itself, and also you can talk to it like a therapist. And if you talk about anything that, oh, I don't want to live anymore, it can call 988 for you. So let's dive deeper. Why we choose this? I know we talk about heart rate, HRE all the time, but there are papers saying that accelerometer data alone can provide more than 90% accuracy in detecting anxiety. And we use exactly the same model that so it's accurate. And when detect, so it also personalized there is 2 minutes training period when you first start using it. And also why we choose this band, because there are papers showing that haptic sensors providing more effective guidance through breathing exercise. And why we choose this, because you can hug it and it feels so therapeutic, yes, and you can talk to it like a therapist. So yeah, that's our architecture, and yeah, thank you. I noticed the time. Thank you. Questions?
Do users have to use the cat?
No. So there are actually 2 parts. That's actually a good question, because I work at Kaiser. So at Kaiser, we may only use this wearable device because it's fully local, private. Nothing goes to the cloud, and it can provide this, therapeutic, physical guiding you through that. But we add it because it makes more effective in intervention. For example, at home, and you want to talk to someone, or if there's something safety emergency crisis situation, it can call 988 or call the therapist that you put the number in it, right? It's more safe.
And could you use a smaller version?
Small, yeah, definitely. We only have 24 hours. I don't have I use ESP32 and MPU 6050, and I don't know how to wrap it. But anyway, in the future, definitely make it smaller. That's easy, yeah.
Also for the cat.
Yeah.
Yeah, you can choose anything you love.
No, and it's really cool.
Thank you. I love the cat.
You said you could also talk to it.
Yes.
Does it talk back to you?
Yes.
Does it meow?
It can meow. It can do anything. It can sing songs. We said like the playlist is really cool. Wanna have it play it for you? Yeah.
Yes.
The idea came from my cat at home in Michigan, who's also my personal therapist, and her name is Meow Meow, so we chose Ferret Cat.
And for the tech, and yeah, for the tech, we use like 11 labs for the vocal.
And it can go to cloud to provide better support, but if you want to stay local, it's totally.
So is the target consumer just folks who have anxiety, or is it folks who mostly have panic attacks?
Yes, the primary target population is people who experiencing panic attacks, and that's actually a big population in the whole United States and also the world. But also you can use it for like when you're experiencing anxiety, because it's the same, like help you ground, like do the 5-5-5 grounding, breathing, right? And also like 5-4-3-2-1 grounding. So I put all those like protocols I use at Kaiser, so it's literally me.
So I feel like now we see a lot of wearables. Like there's like the Oura Ring, there's the Whoop, and there's now wearables for women's health. So how do you, I guess, like how do you get people to use this on top of the other wearables that they have?
Yeah, thank you for that question. That's why we use this little band. It's unique. Because all that, yes, they can detect your HRV, even like other things. They can tell, oh, you're experiencing anxiety right now, but what's next? Maybe it can talk to you, but physical sensing, there are paper in my slides saying that it's more effective than like anything else. Because it's like phygital, it can feel it, especially for panic attacks, because panic attacks is all about physical feeling, like sensations, physiological signal, anything. So that's what brings me here and why I want to do it.
Yeah, and basically like the physical somatic regulation actually activates the parasympathetic nervous system that allows you to calm down. So it's like much more effective than trying to focus on listening.
Yeah, you don't need to use any cognitive, like you just follow it, feel it, right? Feel.
Yeah.
Cool. Thank you.
Thank you.
Thank you.
Last but not least, we have the first finalist of Dodosky's Playground, Paper Cuts.
This one's fair cut. All right, guys, how are you guys doing? How much have you guys been scrolling today? What if there was like another alternative to that? So I know a lot of us scroll over 7.5 hours a day. And I know that most of us aren't actually creating anything. We're just consuming, right? So we want to provide an alternative to that. So welcome to Paper Cuts, where you'll just draw it and we take care of everything else.
Yeah, so a little bit about our tech stack. I don't want to bore you guys with the details. We trained 3 models for our stack. One is CNN, where you're playing a game of Super Smash Bros, a similar game to that. And if say you're playing with your friends and you want to add a new item on the fly, so you can draw. We have a capability, an iPad, or a phone. You can draw like an apple or a sword or a gun or anything, and our CNN recognizes what it is, and then we pass it to our KK agent, which is diffusion, polish, and XCSL. We use techniques like that to sort of refine the assets. I know I'm terrible at drawing, so anything that I scribbled down is not going to look too great. So we use a model that's really quick to sort of polish it up. And then our Moose agent is a neurosymbolic LoRa mechanic composer. Basically what it does is we take a rule graph and we take the semantic meaning that we got from the CNN and we turn it into a playable thing with real interaction mechanics. So if you were to draw a pistol, it recognizes that and it hooks you up to pistol code. Or if you were to draw fire and water, it connects them together and you get steam. Things like that. And we were able to train this on Trainium, and we actually were able to get some crazy speeds of like sub 500 milliseconds. So what that means is you're playing with your friends, you're playing Smash, you want to add in like a sword on the fly. You can draw it in, and like within seconds, it's just in the game, and your friends can use it. And we also have phone controllers. We use Redis for this, just so you can play with your friends, couch party, local or online. And you'll see that there's 2 QR codes. The one on the top is for players, and then the one on the bottom is if you have a drawing device, you can connect to that and draw whatever you want and just like mess with your friends, I guess.
Right. So the idea for this is that instead of consuming, we're giving people another option to create. So you have platforms like Roblox, Scratch, there are all these things out there, but we're the first doing it AI and this fast. So for example, we have this diffusion model, which normally things are really slow in terms of like generative AI, but like you said, you can see a new asset completely wired into your game under 500 milliseconds. So this completely changes the bridge from imagination to interaction. And yeah, so with paper cuts, we're expecting to, we're moving before Roblox, we're moving before all these other companies, and I think we'll be the first to do this and hopefully get a whole new generation of creators making things. So we want you guys to stop scrolling and start scribbling. We're happy to take any questions.
Do you guys have a demo? Do you have a demo at all?
We unfortunately weren't able to do a live demo, but over here, if Caleb, you want to run us through how this would actually look like.
Yeah, so this is our like visual editor. This is for like people who want to make like proper development. So we use like larger VLMs for this, so we don't have like that 500 millisecond latency. When you want to actually make good games, you can use our built-in level editor to add things. And it's not just limited to Smash Bros. Games. We can support platformers, et cetera, et cetera. But once you actually hop into the game, I don't know if we have any pictures. We have modes. No, I don't think we have any pictures. Oh, this is our character creator. You can make characters on the fly as well with AI. But once you're actually in the game, you can. We have like a little iPad app where you can just draw whatever you want, and then there's a drag and drop. We turn the map that you create into like a little mini map, and you can just drag your assets in and just plop them in, and then within seconds they're playable.
How much does this interact with current games? Like, could I paint some stuff and then put it into any sorts of games, or how is that limited?
Yeah, like right now we built off of like the Smash Bros. Game as a scaffold because we all like to play Smash, but it could work with anything really, any sort of game. This is an HTML5 canvas, but I think it was as a proof of concept, but we can work with pretty much any scaffold, any type of game.
So like if I'm a kid who doesn't know anything about AI and isn't going to college, could I do this?
Yeah, I mean, you don't have to, there's no, like Scratch, Roblox. I'm a Roblox developer myself. I've made a few games. And there is like a barrier to entry, right? You have to know how to code. Even though it's a lot easier than being a full-on indie game developer, you still have to know how to code. Even with Scratch, you have to know how to put the blocks in. But with this, all you do is just draw what you want and just plop it in, and our AI does the rest for you. So it removes that barrier to entry almost entirely.
So what part are you drawing and what part are you outsourcing to AI? Like at what point does it just take your drawing and puts it into a game?
Well, we trained a model. If you go back to the tech stack page, we trained a model, the KK1, using diffusion polish. So we have like a doodle art style, obviously, as you can see. And the whole point of that was that we can get really, really quick polishing. So if you draw like a little rough apple and it's a little bit rough around the edges, we have like really, really quick models that will turn it and polish it around the corners and make it into a playable game asset. But it's still like your asset. It keeps your original style and just turns it into something like with a little more polish.
Last but not least, we have Percept for the last finalist in Dodosky's Playground.
Hey everyone, I'm Dean, and this is Percept.
Hi, I'm Sebastian. And I'm Edward.
And I'm Adrian.
So I have a family friend, and they own a restaurant. And so with this restaurant, raise your hand if you have any sort of friends or family who have owned a restaurant before. Anyone? So I see a decent amount of hands. It's actually incredibly hard to get good, engaging content out there. And so we recently had a breakthrough where a few months ago, there was a model called Tribe V2, which was released by Meta. And basically, this maps directly any text or language. It will output activation in the brain. And so coupled with auto research, which was posted by Andre Carpathy, we thought that this would be a really great tool to have.
Yeah, so as Dean mentioned, we are mainly working with 3 models in our infrastructure. The first one is Tribe V2, and then we're also using Redis for the backend and RAG pipeline, and then Pika for the video generation and a lot of the UGC skills and short form skills. And to go more into Tribe a little bit, it takes in those videos, and because it's a digital twin of your brain, it's able to predict the signal activity in different parts of your brain. And so we were able to look at the most important parts of short form content and advertisement, like retention and audio and visual stimulation, and map those to the parts of the brain in the cortex that actually matter.
Absolutely. And this part is basically the part where you make your original video. So in the top left corner, you'd write a short description of what you want, as well as any other settings. And Claude Code would use its skills and MCP to generate a full description of the video for you.
Yeah, so I'll take you guys through kind of like how our overall UI kind of works and how like everything works. So if you can unpause that. All right, so I guess we can't unpause this, so that's pretty bad, but overall, so this is our main brain thing, and this is the model, and so when we load in our video, there should be a video image over there, and there will be many images of our video like covered throughout this bottom part. And so if you run like a slider through it, it could show you different parts of brain activation in the brain 3D model here. And then overall, it will give you a summary number out of 100. We do some mathematics and do some normalizing to get this number. And usually when we have a brain, we want to first normalize to 50 so that once we generate a good video, we could compare it to that normalized value. So how this works is that right now, this line is just a random squiggle because this is just the initial page without the actual MP4. So when you actually load it in, there will be certain like ups and downs. And we want to target the parts in which it's down because that means there's less brain activation, whether it's like values or resources. And then we will run it into our model and it will like segment that MP4 and create it into like a better MP4.
Yeah, and so, yeah. Okay, so the next part is that basically we really want to get we want to get this tool into the hands of people. So even though we can't show it on the slide, we actually have a specific plugin that you can just download directly with the Pika MCP. And so if any of you guys have used Pika, it's incredibly great with generating videos. We were actually able to like have this training loop where basically each iteration of the loop, we have feedback from this brain model and other features from computer vision models. And basically each time we're feeding this reward function, and each iteration, the video gets better. And so we put all of this into a package that's available online. I'll share it with you guys probably later if I can. But yeah, we really want people to just be able to generate content and extremely easy and efficient rather than having to hire a bunch of people and pay a lot of money.
And we're at time. It's just a Q&A.
Yep, thank you guys.
I can start with the first question. So help me understand, what does the brain model get? So I understand like you have a video, you understand engagement on the live, so you figure out auto feedback to make your video better. What does having a brain model specifically in that loop give you as a kind of core part of the technology stack?
So the model is, Meta trained a foundation model, and it just takes in the video and audio and different inputs, and then it just outputs the level of like, I think, blood that your brain gets, and it maps that just as the activity that your brain has in a certain part or region of your brain. And we're basically training to optimize that part and increase the activation in those core parts of the brain.
Yeah, so essentially each different part of the brain is associated with different behaviors, like focus or how much retention you have. And by mapping which areas are more active, we're able to see how a certain video is translating into retention with users.
What's the proxy for the brain data?
So basically, the model that they actually made takes in like voice, it can take in sound and the video. Like, so we put the video into the model because it's allowed to take it after we transform it a few times.
But then not everyone has the same response to each video, right?
So it outputs like a matrix, like 1 frame per second, and there's like 30,000 points on the brain that it actually keeps track of. And it just outputs the signal in those 30,000 points.
And it was trained on about 700 clinical patients, so it's more of an average of how the average person would react to seeing a video, so you get a much better idea of how a population would react to the content.
Could you adjust that? Like a younger population of the same like sex and interest might have one thing that really resonates with them, where a totally different population might have a totally different resonance.
Yeah. So that goes into what we were doing with one of our sponsors, Terac. So they actually allowed us to use like human annotators or like that could kind of like classify data as, because like these brains, they can't really understand text, right, like a human can. So we were thinking about integrating not only like a kind of human reaction trained model, and we were thinking about adding it onto what Meta has. So that's probably something we want to do in the future or something like later.
Thank you, everyone.
All right, now that our finalists have presented their projects, our panel judges are going to go backstage and they're going to deliberate and discuss on who will be the grand prize winners. So another huge round of applause to our panel judges and our finalists. All right, so now that you have all seen the finalist presentations, it's time for you to choose who will be the Hacker's Choice winner. So scan this QR code or go to tinyurl.com/hacker-choice and vote for which of the 10 finalist presentations you thought was the best. I'll give you guys a couple of seconds to scan this QR code, and the winner of this award will receive the Hacker's Choice Award. Last chance. Cool. Another thank you to our sponsors.
We're going to now be moving on to the sponsor prizes. In terms of logistics, sponsors will announce their own winners for their prize tracks. If your team is announced, please stay in your seats. Your sponsors will meet you back in MLK building after closing ceremony. CalHack's tracks are going to be received at the winners meetup that will also be in MLK. And I'm happy to announce our first prize tracks hosted by Fetch AI.
All right, who's excited? Woo!
Yes, finally. Yes, that's my favorite clicker. Hello. I must say I'm really tired. I can feel for you how tired you guys are. So I'm gonna not take long and get you all guys the prizes, and I'm gonna be out of here. Okay, this clicker is gonna be a bit hard for me to deal with. You wanna press it? Well, because I'm looking at this. So I usually say this before I start giving the prizes. You all did an amazing job. We had about 86 projects today submitted. So thank you everybody who's actually managed to build on Fetch. Some were great, some were not able to build exactly what we wanted. But please don't don't get discouraged. There is always an opportunity, and as you know it, I am always in the hackathons, so there will be more prizes and more opportunities to build on Fetch. So the first prize we initially put in for 1,500, that stays, second prize 1,000, and third prize 500. But as you know all, who have seen me before, I always add more prizes. Because they were so great projects, I had to add more. So we have got, can we go on? Do we have more listed here? We have got additional 4 more prizes and 2 additional mentions. So can we just move on to the next? So the first prize goes to, yeah, these are the special prizes that we added. LifeLink. Great project. Well done, guys. Great execution, and we loved the project. So please feel free to come and see me after. We would like to explore how the project can be built further. Constructor was another great one. Thank you, guys. I don't know where everybody is, but yes, hello. Third one, Aerofreight AI. Great project. We could not actually make decision of which one we wanted to give the prize. So if you guys have been missed on these, we definitely liked your project, which will be coming up probably in the next slide. Third one, Care Loop. There were 2 very good projects. We couldn't decide, so we decided to add additional third prize. So here we are with 2 additional prize.
So I'll be announcing the special prizes that we have. The special Agentverse prize goes to Quorum. The special Fetch Business prize goes to AgriBroker. And the special Fetch Health prize goes to Fetch Health. The special Social Group prize goes to Firefly.
Well done, guys. Give yourself a big round of applause.
And there were 2 more great projects which use Fetch in a very unique way. They are honorable mentions for Vanguard and Baymax. Thank you.
Well done. Just to mention, see, I always do this last bit, which is nice touch. We are doing Fetch AI after party tomorrow. And we will be sharing the information in the general channel of the Slack. So if you are free, tomorrow 4 to 6, there will be free drinks for you guys to enjoy. So please feel free to join us. There will be some discussions, how the projects, and every person will have opportunity to talk about internships. So thank you very much, everybody. Great stuff.
All right, thank you, Fetch. Next up, Claude by Anthropic.
Yeah, do I have a clicker? Yes. Hey everyone, this is Marcus. These past 2 days have been so much fun. For those who came to our sponsor booth in the past 2 days just to learn more about Claude, the opportunities where we're engaging with students, and also just time to talk about implementing your projects, thank you so much. We had a great time chatting with y'all. All right, so to go on very briefly, our challenge in terms of best use of Claude, we really cared about hackers being able to articulate the scale and urgency of a problem and relating the impact their solution had for an end user to every layer of their tech. And so as a reminder, our prize, we're offering $5,000 in API credits, an office hour with our applied AI team, and an invitation to visit our office in SF. With that being said, our winner is Safe Streets. Yeah. Winners, I'll reach out for next steps, but thank you all again.
Up next, we'll have the Token Company.
Hello, everyone. All right, hello, everyone. My name is Rasmus. I'm from the Token Company. I have with me here Alan and Taha as well. And for you, those who you don't know, We make machine learning models for compressing LLM input smaller, and we're backed by Y Combinator and HF0. And for our track, the challenge was to build a compression model or algorithm to make LLM context smaller. And for rewards, we have, for the first place finisher, we have $2,000 in cash, and also Claude Code 5x for 6 months for the everyone on the winning team, and also a boosted track for interviews as well. And for the second place winner, we'll have $1,000 for cash prize. And Taha will now announce the winners.
Yep, so first place we have Recompress, and second place we have Accordion.
Thank you very much.
Great. Up next, we have prizes from Redis.
Woo! Hello, everyone. Yes, we saw some amazing use of Redis, from semantic caching to agent memory systems to some really novel interesting uses of vector search. So first, I'd love to give out. Well, first we'll talk about what were you doing. So best creativity, originality, and best technical implementation. Those are the criteria we're judging on. There is a lot. I could list a lot of honorable mentions, but I want to call out 2 of my favorite ones. One was Ngram, very cool use of robotic work there. And also Sentinel, a lot of really impressive technical work there. So those are the 2 honorable mentions. But the winner, with Mac Minis, 1 per teammate, 25,000 in cloud credits for the full team, as well as Timbuktu backpacks, we have Forge.
Up next, we have Armor IQ.
Hi guys, so unfortunately Armor's not here, so I'll present on behalf of them. So the challenge was for the best use of Armor IQ platform to build secure agents, and the prize that they are giving out is a Nintendo Switch 2, and the winner is Aegis.
Thank you, Armor IQ. Up next, we have BrowserBase.
Hey everyone, what's up, How we doing? Okay, I'll keep this short. Thank you all for hacking this week. This weekend, we had over 100 people build with BrowserBase. It was super awesome to see all the things you guys built. And if I can ever be a resource to any of you guys, ping me in Slack. I'm happy to give you guys credits and help you guys keep building cool stuff. We'll have a 3rd, 2nd, and 1st place prize. 3rd and 2nd will get exclusive, never to be produced again, vintage merch and credits. And 1st place will win our $2,000 cash prize. So, I don't know how to click the next button. I got it. Okay, so for 3rd place, we have Trade. For 2nd place, we have Constructa. And then 1st place, Narcor. So thank you guys, congratulations, and meet me at reception to get your prizes. Thank you guys.
Thank you, BrowserBase. Up next, we have Sentry.
Right, hey everybody. So, for building the most complete self-healing loop that we've seen today, or this weekend, and solving a real gap in observability website monitoring, and the prize was, or the conditions were, featuring the best use of the Sentry API, we want to give big congratulations to Canary. You guys are getting an interview and Nintendo Switches, so woo!
Thank you, Sentry. Up next, we have Simular.
Hey guys, how are you doing? So we got 2 winners here. The first thing is focusing on people who need medical attention. So, okay. So I like the part that integrate our open source repo, Simulant, to be a backbone for computer control. A second thing, use our 24/7 agentic cloud worker site to stress test our product. And the special thing is that that site play as a multi-agent orchestration where they use different persona, like old grandpa or Gen Z, to showcase the QA versatility. I got this from our marketing. Let me see how I can do that. So I'm awarding the best use of Simulate for Teen Sting and Teen Tenley.
Thank you, Similar. Up next, we have PaleBlue.ai.
Hello. So, are you guys ready? We have 3 prizes for best use of token router, the unified AI model gateway. So, here are the credits. 3rd place awards is a team that uses brain simulation model to auto-edit educational videos for peak engagement. Winner is retention. Woo! And the team that won 2nd place matches pre-surgery patients with verified people who've had the exact same procedure. That is Pulse AI. Yay. Last but not the least, the 1st place team is an AI-native municipal 311 system that triage calls and auto-files permits in under 60 seconds. That is 311.ai. Yay! Okay, you guys can meet me later at MLK for photos and further information. Thank you.
Thank you, Token Router. Up next, we have Arise.
Hello again, everybody. Thank you for staying this long. We have just the one prize. We were very impressed at how many people got involved in our obscure and nerdy product. Thank you very much. The winner of our $1,000 cash prize goes to Jugad. And like the other sponsors, please come and meet us at MLK immediately for pictures and so I can get your details. Thanks, everybody.
Thank you, Arise. Up next is Pika.
Hello, everyone. Yeah, I'm really excited to be here, and we saw so many good projects. And so for our prizes, we have $500 cash prize, plus office visit and our 10K credits, and special merge for first prize. And for second, we have $300 cash prize and office visit, and PKMCP credits, 10K as well. And for third, we have $200 cash prize and office visit and Pika credits, 5K. And just to mention, our intern got her internship because of the office visit. And our winners are first place, Sanya. So they did a really good job with like hand sign language, and second place is reseller. Third place is Smoggy. Congratulations.
Thank you, Pika. Up next is QNX.
So you've been working all night, and this has been very long, so I'm going to keep it quite short. But I did want to just say, we totally appreciate everybody who participated. We know that doing an embedded project takes a lot more work, and so therefore doing a physical AI system is a lot of risk in terms of what you guys are able to do and what you can pull off in that 24 hours. So for everybody who participated in our track, thank you. Really appreciate it. Without further ado, we've got a $1,000 main winner and 2 runner-up prizes. It's pretty easy. Moggy and Safe Tank were our runners-up, and Vanguard Telematics was our main winner. So thanks so much, everybody.
Thank you, QNX. Up next is Cognition.
Woo! Thank you, everybody. We saw some amazing projects this weekend, and we are so excited to announce some of our winners. For our prize, we are giving out a sunset cruise on the sickest boat party the Bay has ever seen. And for our winner, which is getting the sunset cruise with 30 of their friends, plus 500 Devon credits, it is Browser Delta. Excellent project. And as a honorable mention, again, everybody had amazing projects. So glad to check those out. Thank you, anyone that joined our track. But Refactorica had an amazing work, as well as Alpha Research. So if you were mentioned here, and if you got the Sunset Cruise, come find me after. Can't wait to talk logistics. Thank you, everyone. Great hackathon.
Thank you, Cognition. Up next is Deepgram.
All right, Berkeley. Congratulations on making it through the hackathon. I am Naomi Kerrigan. I am the community engineer at Deepgram. I think I've seen all of you here for just about as long as I've been here. Big thank you to all of you for the massive excitement about Deepgram's track. We had over 140 submissions. That was so many. I am still working through getting responses out to everyone, but I would love to give a shout out to Aside.dev, our grand prize winners. They get 4 Nintendo Switch 2s, one for each of them. They built some really cool wearable technology that narrates everything going on around you, so that if you or someone in your life happens to have a vision impairment, you can still get the same information that somebody who has sight might be able to get. And with that, thank you all.
Thank you, Deepgram. Up next is Ultimate Bots.
As a sports league for robots and physical AI, we're so excited to see so many projects building in robotics. And without further ado, for the third place, for $500, we're awarding a prize to a team that built improvements to the simulation stack. It's XSGen. For the second place, the team that created the whole pipeline to train new motions for humanoid robots and created a punch for one of our Unitree G1s is the team RoboJab, getting $1,000. And the final prize, the first place, goes to Omniscient, the team that built control and recovery mechanism for robot arms and hands. Thank you so much.
Thank you, Ultimate Bots. Up next, we have Orcs.
Well, good afternoon, everyone. I'm a product manager at Orcus, and I was really impressed with how AI forward all the students were. So congratulations to all of you for keeping up with where AI is taking us. So we had 2 categories for prizes. One was a $250 cash prize, and the other one was a $750 cash prize. The first one, the $250 cash prize, congratulations to Pulse AI. Pulse AI helps patients make better medical decisions by connecting them with verified people who have actually gone through the exact same procedure. The other cash prize, $750 cash prize, goes to Braille AI. It's a 2-way voice for the deaf and the blind. Both your teams, congratulations to you. You showcased how you can use Orcus to take both your agents and workflows and make them durable in production.
Thank you, Orcs. Up next, we have Cognichip.
Woo. Hi, everyone. I'm Vince. I'm with Cognichip, and we are a semiconductor company creating the first physics-informed foundation model for chip design with the goal of accelerating and simplifying chip design process. But enough about us. without further ado, the winner for the best use of our Cognichip platform will get a tiny tape-out credit, meaning an opportunity to actually fabricate the chip design, actually see how it works. So the winner of that track is Silicon YOLO. Woo! So they designed a low-cost, very tiny chip that can spot and identify objects in real time using a fraction of the power of existing solutions. Super cool. And also honorable mention to Radical and to Diffusion Accelerator for their high-quality design and methodology and quality final deliverable. Thank you so much.
Thank you, Cognichip. Up next, we have Terak.
Hey everyone, really appreciated you participating in our track and using Terak's MCP to provide your agents with humans in the loop. It was really impressive to see what you guys built and just like grinding it through the night and just operating on Red Bull. Love to see it. In the end though, we got to pick 2 winners. So for the second place, $500 cash prize, bring it up for Captain Dudowski. And then the first place, Match Vision for a $1,000 cash prize. Congratulations.
Thank you, Terak. As last but not least, for our sponsor prizes, we have Band.
All right, hello guys. So I'll be presenting for Band. So we had $1,000 in Amazon credits and gift cards to give out. If the slides can move. Yeah, best use of agent-to-agent communication. And then the winner is Triage. Come find me at MLK. Thank you.
All right, so now that we've gone through all our sponsor prizes, it's time for our general prizes. Who's excited? So we're going to start off with some special prizes that we offered. Starting with Best UI UX, getting Kodak cameras. And the winner is Paper Cuts.
Next up, we have Best Solo Hack for the prize of an XGIMI projector, and the winner is Immuniverse.
Up next, we have the most technical hack, getting FlashForge 3D printers, and the winner is Workbench.
Next up, the best Golden Bear hack for the best Berkeley hack. The prize of $100 Cal Student Store gift cards goes to FizzBiz.
Next up, best beginner hack, getting AirPods 4 with noise cancellation is Marketverse.
Right. Hacker's Choice Award, the one that you voted on earlier, they will be receiving mechanical keyboards, and the winner is Inspector.
Most questionable use of 24 hours. They will be receiving Lego sets, and the winner is Moggy. All right, it's time for our grand prizes. Our panelist judges have deliberated long and hard, and we now have our winners. Starting with Dudowski's World, receiving $5,000 in cash. Drumroll, please. Lucid Voice. By the way, if you're a grand prize winner, come on stage after the ceremony and you will take some photos with some large checks.
Next up, Dudowski's Toolbox. Next up, Dudowski's Toolbox for $5,000 in cash.
Drumroll, please.
We have Iron Book.
Next up for Didowski's Lab, also receiving $5,000 in cash. Drum roll, please. Theracat.
Last but not least, Didowski's Playground, also receiving $5,000 in cash. We have
Drum roll, please. Paper Cuts.
All right, now for the Skydeck Grand Prize. This is guaranteed admission to Skydeck's Pad 13 Incubator Program, and the prize goes to Theracat.
And now, we have an announcement. CalHacks 13.0, our next flagship event. It's happening. October 23rd to 25th, 2026, at the Palace of Fine Arts in San Francisco with new and improved Wi-Fi. Join our email list at hackberkeley.org. Follow us on Instagram at CalHacks, and we can't wait to see you there.
Thank you, everyone.
Now, as you head back to MLK, please make sure to pick up trash around you. Check for your valuables. Return any hardware that you borrowed if you haven't already. And it has been 0 minutes, 0 days, 0 hours, 0 minutes, and 0 seconds since we last saw each other. And we're going to start counting back up till next time. Thank you.
Thank you, everyone.
See you at 13.0 this fall.